Good afternoon, everyone. Thank you for joining us today for our Scheduling 101 webinar. Today, we're going to discuss the basics of job scheduling in Epicor. I'm Sue Brzee, the Marketing Director here at 2W Technologies, and be the moderator today. If at any time during the presentation today you have questions, you can send them through the question box on your screen. There'll be an interactive Q&A at the end, and we'll try to get to all the questions then. We do have a lot of you with us today, so if you have to bail before we get to your questions, please reply to the webinar email, and we'll make sure that we at least get your answer back to you at some point. The presenters today are going to be Zach Williams, an Epicor consultant here at 2W Tech, and Sam Plummer, who is our Epicor practice manager. For those of you who might not be familiar with us here at 2W Technologies, we are a technology service provider and an Epicor value-added reseller. We also offer Microsoft Cloud, security, data analytics, and IT infrastructure solutions. We are also both an Epicor and a Microsoft Gold partner. I'm going to now turn it over to Sam to get us going. Sam?
Well, thank you, Sue. And everyone in attendance out there in webinar land, thank you for spending a little bit of time with us today. We're hoping to be able to provide a little bit of value for everybody that's attending. And in particular, the first thing I want to talk about is what you see on this slide. In particular, what are the benefits? What are the business benefits that we're going to achieve from getting better at using the scheduling tools available to us in Epicor? Well, one of those obviously is a more accurate representation of what the workload in your shop or in your plants in multi-plant environments looks like. And especially the ability to look down at individual resource or resource group levels and determine where perhaps the bottlenecks are in your production, given a specific mix of work and jobs that are in that shop at any given time. So I think that there's value there. And where we can drive up and start talking about other benefits are in downstream processes, particularly the ability to make decisions like rerouting or changing the particular manufacturing process that we're going to do on individual jobs or on groups of jobs based on that load versus capacity relationship. So I think, and in many cases, another option that's available to many manufacturers is to outsource some of that work in order to better optimize the flow of work through the shop. So certainly that improved decision-making process definitely applies within production operations, but then also flows downstream to your material planners by having more accurate predictions of when work will actually occur in the shop. It allows your material planners and buyers to time the arrival of materials to better support those manufacturing operations. And either extreme, as you well know, is a problem. Having too much material in plant too far in advance of when it will be consumed is a problem, both from a cash point of view, but also from a physical space point of view. And then also, obviously, the opposite problem is probably even a little bit more serious, not having the materials you need when you have the time to do the work. So better scheduling will improve that feedback that you're able to give to your buyers and planners in terms of when to have materials in the shop. And at the end of the day, besides, probably higher profitability, we're going to be able to improve, some key metrics, ship dates in terms of promised versus shipped, and that will drive an increase in customer satisfaction. So I think, these are all probably self-evident, but things that we need to talk about a little bit. So, and certainly, I'm sure you can all think within your particular businesses of other examples. Now, before I hand things over to Zach, I do want to introduce just a couple of key concepts, and Zach's going to drive down into these in a lot more detail here in just a few minutes. If there's only one takeaway that you get from today's webinar, it is a few definitions. And the first of those is the idea of load, the shop load. that is basically the amount of work that's in your manufacturing facility, typically in Epicor owing to jobs. That's the amount of work you have to do, is what we define as load and what Epicor defines as load. The second key concept, and really scheduling deals with the interplay of load and capacity. Capacity is the available time on your resources. And Zach's going to go through some examples of both load and capacity, but then he'll also talk about how scheduling helps us manage those relationships. Just one more thing that I want to kind of preview a little bit is the idea that really, and Zach will reinforce this, and I think those who are doing scheduling today will support this. In many ways, we should view scheduling as a journey that we have to undertake. In other words, we advise that you crawl and then walk and then run with scheduling. And there's a lot of inputs and variables and options, but don't get confused by those, because I think Zach is going to tell you some really key things to focus on, again, early in your scheduling journey as you learn to crawl first with the tools you have and then move to the next stage. So enough about intros. Here's Zach to really get into the meat and potatoes for you.
Thanks, Sam. Thanks for the intro. Thanks for those definitions too, because that is going to be key to the conversation. It's this relationship between load versus capacity. So that's what we're going to be focusing on a lot. So how do we get started with scheduling? What are the prerequisites? Really, everything comes from our methods, our engineering revisions, and our job engineering details. If we don't have the right details put in there, we're not going to get an accurate schedule. So that's what we're going to be focusing on. Data input is getting our methods to look right. And if you've been using Epicor for any given amount of time, maybe you have methods in already. When's the last time you've reviewed them? Do your estimates look like your actuals? Have you ever reviewed them? It may be a key reason why you haven't been using scheduling in Epicor up until this point. It's because it's hard to see the benefit until we get those estimates correct. So what are we looking at when we look at our methods? On our load side, we're looking at our operations. So here we can see simple part here. We have 10 operations listed. What are we using within this operation setup though to define our load? Primarily, we're looking at our production standards. How many pieces per hour have we said does it take this operation produce? So in this instance, 100 pieces per hour. There's other ways we can look at standard. We can look at hours per piece, minutes per piece. We can also look at fixed hours. Maybe the time span spent on an operation isn't dependent on the quantity for the job. Maybe you have a fixed 1 hour inspection time that you need for an operation. Maybe you have oven time. A part's gotta bake for 3 hours. It doesn't matter if it's one part or 1,000 parts. So that's where we'd use fixed hours instead of pieces per. So that's our production load. We also have setup load. So that comes from this section here. This is initially set as a fixed hour type load. So in this instance, we're saying we have 1 hour of setup before we begin production on this saw operation. But we also have variables available to us here too. We have dynamic settings. So we could set an additional setup quantity of 1,000 pieces and additional setup hours of half an hour. So what that does, it says every time I have a job load and I hit 1,000 pieces on my run quantity, I want to add an additional half hour of setup time to my load. I might have to change out a drill bit. I might have to change out, you know, a saw blade. Maybe there's something where a certain run quantity impacts how much setup time I have. So that's what we're going to use these two bottom field for under our initial setup time. So initially, when you're scheduling and first setting up your methods, this is what we're focusing on: the production time and the setup time. Once we have that established, then we can start looking at some of the more advanced features. So scheduling blocks, for instance. What do scheduling blocks do for it? Well, we can take that load. So let's say when we schedule this operations for 8 hours, if we leave it at scheduling blocks of 1, which it is by default, it'll say I want to schedule that 8 hours to 1 saw resource. But I can also split that between multiple resources. So by changing that to 2, I'm saying when you schedule, don't just schedule to 1 saw for 8 hours, schedule to 2 saw resources for 4 hours apiece. So what does that do for us? That reduces our overall date timeline of the job, and we can produce a job quicker by throwing more resources at it. Under that, the start, finish, to finish. What is that? That's this operation's relationship to the previous operation. So by default, and in most scenarios, it's going to be a finish to start relationship. So when the previous op finishes, I want to start this operation. But we also have these start to start and finish to finish options. What does that do? Well, say we have a material prep operation and a CNC programming operation that happened in the beginning of the job. Well, those two things can happen at the same time. We don't need to finish getting material prep done to do our programming. So we might want to define op 20 as start to start. So op 10 and op 20 will both be injected in our schedule at the same time. Again, reducing our overall runtime for the job. So those are the key fields that are going to define the load side of our schedule. On the other side, we're going to have our capacity planning. And where's that coming from? That's coming from the resources themselves. So when we schedule load into the system, it's applied directly to our resources. So two key fields here are our production calendar assigned to our resource and the finite capacity checkbox. So the calendar assigned to our resource is giving us our capacity bucket. So if we look here, our saw resource is assigned to the 5-day, 8-hour production calendar. Here's our calendar down here. We have 8 hours scheduled Monday through Friday. So that's the given capacity for that calendar and for that resource. I can schedule 8 hours of work on that saw. Depending on our selection, though, finite capacity, we may be able to go beyond that 8 hours. So when do we select finite capacity? Why do we select finite capacity? So when a resource is defined as finite, we're saying we want to limit the load placed on that resource in any given bucket. So by leaving it unchecked, we're saying you can schedule infinitely, we can make adjustments, we can move things around to get more capacity into that resource. Typically, I'd say things like saws or machines are always going to be finite. You can't just have more machine at any given time. You're stuck with the capacity you get. I know from past projects, people are nervous about checking this box. They think it's going to limit their schedule, and it's going to create all these date changes if they define their resources as finite. But we're not limited to running a finite schedule just because we check that box. Later on, we'll see when we run our schedule itself, we can choose. Do we want to run it infinitely? Do we want to run it finitely? So just by checking this doesn't limit our options for this resource. So from a setup standpoint, though, I think it reflects what reality is. Is this resource finite? Is it a machine that we can't, we don't ever want to go beyond that eight hours on? If so, I would say select that checkbox. We have our load side on our operations. We have our capacity side on our resources. What does that get us? What kind of deliverables do we have within the system? What kind of tool sets are available to us? We have Gantt charts, which are presented in job and resource scheduling boards. We have reporting options, such as the shop load and priority dispatch report. We also get things like purchasing suggestions. That's even if we're not using full-blown scheduling in the system, you might be using new PO suggestions, and that's all generated from our schedule. Materials are related to operations. When those operations are scheduled to start, that's the requirement date we're getting on our materials. So even if we're not looking at scheduling from an operation standpoint, it's still important for our materials as well. So let's look at those boards. So the job scheduling board, I mean, this is the most basic presentation of our Gantt chart. We can right click on any job number, open with job scheduling board, and it gives us this view of the timeline for this job. So I can see it starts on April 1st and it's scheduled to be completed on the 6th. I can hit my plus sign on my folder here and see the breakdown operationally and see how long each of these operations are taking. There might be a big gap between operations and causing our completion date to be pushed out. So how do I identify that? Well, that's where our resource scheduling board or multiple resource scheduling board comes into play. Here we can see our SAW resource again, and we can see all the jobs scheduled to run on that SAW. So from this, I can tell this has probably been marked finite. It's a finite schedule because my jobs aren't stacked. One is scheduled to start when the other one completes. You can also see that these are MRP jobs scheduled on this. Those of you running MRP, this probably looks familiar, where you get a temporary job number before the job is firmed. Just because that job's not firm, though, doesn't mean it's not putting load into our schedule. So that's often misinterpreted, that MRP jobs are just suggestions. No, they're putting load on your system. So just make note of that. We also have reporting options available to us. So shop load is our good 10,000 foot view of our shop load. We can see by resource group or by department our load and capacity that's currently in our schedule. So this is generated in buckets. There's some options you have on the report screen, but so here I can see the week of 3/20. I have 48 hours of load with 80 hours of capacity. So I still have some remaining capacity if I wanted to throw more at my SAW resource group. The priority dispatch then gives the detailed view of that same load. So I can look at my individual SAW resource, see jobs assigned to it, what that load and quantity start date looks like. Priority dispatch will also give you some text lines here saying this is current work. So when it says that, that means that's something that's available to be done right away. So you might use priority dispatch then to prioritize your jobs. I might have 10 jobs that I'll say current work. I can prioritize them and say, well, you know what, this job, I want to make sure it gets run first. So I can use this as it says, a dispatch report and tell my operator which jobs I want to run first. we often say planning and scheduling, and there is a difference between the two things. So typically, when we're talking about scheduling, it's the immediate future. So our schedule is what's happening today on the shop floor, what's happening this week, what's happening next week. I mean, that's when we talk schedule, it's usually our firm schedule that we know is going to match what's happening on the shop floor. Planning is typically beyond that horizon. So those are things, you know, I've scheduled jobs for next month. I'm planning for them. I want to make sure, you know, they're assigned to resources. I have materials on order, but it's likely that things could change before then. So it's not my firm schedule then. And we call that our finite horizon. We've seen this before. So this is back on our resource setup here. So the finite horizon, we can actually dictate how we want the scheduling engine to pick up finite capacity for that resource. So by marking it as 30 here, we're saying everything from today to 30 days out, if I'm running a finite schedule, define this resource as finite. I don't want to schedule it infinitely. Beyond that 30-day horizon, go ahead and schedule it infinitely. Get it in the schedule, give me my best completion dates from an infinite schedule beyond that horizon, because things are likely going to change. I'm probably going to run global rescheduling at some point and realign my start dates. And then once it picks up the horizon again, then it'll be finite again. Once we get it in our 30-day horizon, that resource gets picked up as finite again. So again, this is where that finite checkbox, just because it's checked, doesn't mean I always have to plan on this resource being a finite resource. I can run my schedule infinitely, or I can define a finite horizon like this. But what do these different scheduling scenarios look like when we're talking about infinite and finite? Our scheduling boards are a good representation of what these differences look like. So an infinite schedule, if I run an infinite schedule, you can see I got 5 different jobs all stacked on cell 1 at the same time. So it's even though I've defined it as a finite resource, because I've run my scheduling infinitely, it's going ahead and putting all that load on at the same time, because that's what my require by date dictates. You can also see that nothing has been put on SAW 2, because as far as the scheduling engine is concerned, SAW 1 is infinite, so I can put everything there. I can take these jobs from the scheduling board and I can physically drag and drop any of these down to SAW 2. You'll get a prompt that says, do you want to reschedule the job? You can say yes, and you can actually move around your operations and your resources from these scheduling boards. So they're not just visual, they're interactive as well. Same load of 5 jobs running a finite schedule. You can see the difference here. Instead of all being stacked on SAW 1 at the same time, it's done the work I just talked about in the previous slide for me. So instead of having to drag these down to SAW 2 to disperse my load, you know, scheduling engine does that for me. It says run job 40 on SAW 1, run job 41 on SAW 2. Don't schedule 42 and 43 at the same time, push those out to the next day. So this is how I prefer to run and see my schedule. This is letting the system do the work for me. I've defined my capacities, tell me when I can start these operations. So that's what finite scheduling gives for us. Here's another example of a finite schedule using scheduling blocks that I talked about earlier in the operation. So this, when I have 2 scheduling blocks assigned, you can see here, job 45 is scheduled on both SAW 1 and SAW 2 to run at the same time, and it cuts that timeline in half. So you can see here that's running about a day. That same job load is running about 2 days here if I don't do that. So maybe you're presented with a schedule like this in your finite scheduling. You're not limited to those scheduling blocks in your engineering workbench either. I can make that adjustment on an individual job. So if I have a priority job, I can say, you know what, I want to change the scheduling blocks on this for just this job, change it on my operation, reschedule, because I want to make sure that's done by the 25th. So scheduling blocks aren't limited to static revisions that can be changed in the job itself. So that's kind of our start and our endpoints. Like, there's the data we put in, and those are the results we get. So how are we actually creating our jobs in the middle there? There's a few ways. We can create jobs via MRP. We can individually schedule jobs. And then once we have those schedules, we can reprocess our schedule using global scheduling. So some of you might be using MRP. What MRP does, it's going to look through our supply and demand records throughout the system, look for manufacturing requirements, and create MRP jobs where it sees the need. Typically, this is a scheduled process that runs overnight, not so we don't interfere with the current schedule. And we can see within the process stream, we can choose, do we run this as a finite schedule, or leave it unchecked and have it be infinite? So it's a business decision. Maybe we want our initial MRP to run infinitely so that we can review it, and maybe we have global scheduling pick it up later on to run it finitely. But we have that option within the process itself, how we want to generate that. And maybe we don't have MRP, we're not using MRP. Maybe we're a smaller shop and we're just handling a lighter job load. We can individually schedule jobs as well. Automatically scheduled or they can be automatically scheduled when you do things like make quick jobs, create jobs from Order Job Wizard, the planning workbench, or if you're just in job entry, when you release a job, you'll get this pop-up usually. So if you want to schedule the job now you've released it, and we have some options here as well. Again, we can choose, do we want to run it at finite capacity? We also get to choose in this individual job scheduling, do we want to forward or backwards schedule this job? So this is a good tool if we want to prioritize or expedite a job for a customer. Maybe a customer calls and says, hey, I need this as fast as I can get it. When can I get this job? So you can go into the job, even if it's scheduled already, actions, schedule, job scheduling, forward schedule the job from today, tomorrow, whatever start date you want, leave finite capacity off, schedule the job, and what you'll get in return is essentially your best completion date that you can provide to the customer then. Once we have jobs in the system already via MRP or individually scheduling, we're probably going to want a global reschedule at some point. We want, you may have fallen behind on a week or gotten ahead on a week. So global scheduling will let us run all of our open job load, do scheduling again, and essentially spit out a new schedule for us. This is a two-part process. So the first thing we need to do is run the calculate global scheduling order process. And what this does for us is it ranks our jobs. It looks at required by dates, schedule locks, priority codes. I mean, these are all kind of advanced scheduling features we're not going to get into today, but there are ways of prioritizing jobs and ranking them. So it gives them an actual ranking number, 1 through whatever. And then when we pass it off the second part of our process, global scheduling, it'll take that ranked order and schedule the jobs in that sequential order. So that's how the scheduling engine knows what to do first. It takes the ranked order and then schedules job by job. So I wouldn't recommend doing this every night. I think running global scheduling once a week, like over the weekend, is a good way to realign your schedule fresh every week. Doing it every night, you're essentially going to wake up every morning to a new schedule. So that's probably going to be overwhelming and not helpful in most circumstances. But weekly, bi-weekly, that's a good starting point for global scheduling. So that covered the basics. I mean, we wanted to highlight some key setup things on the front end, show some of the tool sets available to you once we have a schedule, so our Gantt charts and our reporting, and you know, just kind of go through the process of creating a schedule. You know, Sam said this in the beginning. Scheduling isn't a project that you start and finish. It's an ongoing project for any company. As your parts change, as your shop floor changes, as you get more efficient. I mean, you're going to want to update estimates. You're going to want to use more of your scheduling tools because you want to reflect reality in your Epicor schedule, because then you can plan better, you can give customers better lead times, better on-time shipments. It's all centered around your schedule. So hopefully this presentation highlighted a couple of things for you, showed you some things maybe you're not using, and gets you thinking about your schedule. So we'll open it up to some Q&A now. I think I'll pass it over to Sue again, see if she has any questions for us.
Yep, we have a handful that came in. So thanks, guys. That was a great presentation. All right, let's start with the first one. Zach, at one point a couple slides ago, this question came in. I'm sorry, I should have marked the slide at the time, but I didn't. They want to know what the difference between the colors when listing the same job, and I believe it was like the red and the yellow.
Yeah, there's so the yellow is going to be it's what's called the what if schedule. So when I drag and drop that, it's just going to move the yellow portion. You'll get that prompt that says you want to reschedule this job. You don't have to reschedule it at that point. You can just say no and leave that, and you can actually have sequential schedules that you can review at one time. Only one's going to be your firm schedule, though. The yellow one's what's called the what if schedule.
Okay, and I should have reminded everyone, if you still have a question, go ahead and send it. It's not too late. We'll just keep adding them on until we get through them all. All right, next question. Is there a way to turn off the MRP unfirmed job demand when showing impact on the schedule or purchasing module?
No. I mean, once MRP puts that job in, it's finding some reason to make that job and wants to put that load into your schedule. So that's another part of cleanup probably for a scheduling project, is if you're getting a bunch of MRP demand that you don't really want, that probably means your planning parameters in the part are wrong too, or you need to adjust your lot sizing, something like that. But it's the same load as any other load.
Okay, and sticking with this because I think it's kind of on topic. This question is, I'm getting a mass of unfirmed jobs clogging my schedule. Do I have to go into each individual job, then firm and delete the job?
Yes, but again, that's usually indicative of a problem with your MRP setup. I don't know, Sam, do you have any thoughts on that?
Yeah, I was actually going to say that, again, the tool is responding to demand. MRP is seeing demand for those parts. Perhaps they're a long way out in the future, or perhaps it's kind of messy historical demand. Maybe we have some old sales orders out there that were never fulfilled and properly completed and closed, and so therefore we're getting what I would call historical demand again. So there's probably some data hygiene that needs to happen to clean those up. Find out what the source of that demand is, and if it's not real demand, get rid of it. close the sales order, or, cancel the transfer order, or wherever that demand is coming from, let's get it cleaned up. And that way MRP is going to actually be responding to real demand that you want to plan to.
Okay, next question. Is that MRP a separate module?
Yes.
Yes.
Yeah. You don't need MRP to run scheduling in Epicor.
A lot of times I like to explain that MRP, if we thought of a Venn diagram, it is the superset of all the scheduling processes and all the PO suggestion processes, along with the functionality to evaluate demand from forecast, from jobs, from site transfers, and from sales orders and from inventory. So, MRP is a big beast, and scheduling is a subset of the functionality of MRP. But just to be clear, it is a separately licensed module and is really most useful for repetitive manufacturers. In other words, anyone that repeatedly produces the same or similar parts over a period of time.
Okay, next question. Can you turn off the what if schedule?
No, there's always going to be one what if schedule lying in conjunction. Probably warrants a follow-up question as to why you'd want to turn it off, but no, there's no way to just flat out turn it off.
Okay, next question. When you have supplier lead times and part maintenance, is there a way to change these lead times globally if your supplier has increased their lead times?
I would say yes, through the DMT.
Yeah, DMT is probably your best tool for that.
Okay, hold on.
Or an updatable dashboard if you want to build one of those.
Okay, how about our dispatch list does not show the current work in process or 100% complete through prior operation to denote what is currently at a work center?
That would usually indicate that operations aren't being completed at previous operations, either being underproduced or not being marked completed. Sam, can you think of another reason why that wouldn't be showing up as current?
So an operation, assuming it's the second or later operation, would not show as current, to your point, Zach, if the prior operation has not been marked as complete. That's really the only circumstance I can think of off the top of my head.
Yeah, there's and there are ways to force that, I guess, and some more advanced features. When we looked at the scheduling factors before, there's a send ahead where you can kind of offset start times rather than traditional finish to start. So you might want to look at that send ahead type. Maybe you can start the next operation, once so many pieces have been produced. So that's another feature that you could look at.
All right, next question. If you run global scheduling, will it run for everything or can you have multiple schedules?
You can lock jobs in job entry. It's on the header tab of your job. Lower right hand is next to priority code. So when you lock it, you can lock that particular job in your schedule if you don't want it to be picked up by global scheduling. So hopefully that's what you're looking for.
I'm not sure if I kind of interpreted that question a little bit differently. I think the question may have been, are there filters available in global scheduling? And I do believe that I don't have the screen up in front of me, but there are some filters. Obviously, one of the big ones is by site. So in other words, if we have 3 sites and we only want to reschedule jobs in site number 1 or plant number 1, depending on which language we speak in Epicor, we can filter global scheduling by site. I believe there's also options in global scheduling to filter perhaps by the planner code, which is or by product group. Those are typically the mechanisms that allow you to, kind of subset your production management activities, the planner code or the product group associated with your jobs.
And I think that's only MRP. I pulled it up in 10.2.700, and it looks like the only filters we have available in global scheduling at site right now. So they might have changed that, but MRP I know you can run by planner, I believe. So.
Okay, next question. Is there a way to set up the schedule to run 2 assemblies at the same time? I saw you mention start to start for operations and have main assemblies running while sub-assemblies are being produced to have the main assembly ready for when the sub-assembly is complete instead of just starting. That was a mouthful, guys, sorry.
So by default, from a job structure point of view, sub-assemblies at the same level are they are required at the same time. So in other words, if we're, going to machine the left half of a gear case, and that's represented as a sub-assembly, and then we're also going to machine the right half of that gear case, which would be another sub-assembly, by default, when we schedule that job, Epicor is going to want those, they're required or they're needed up at level 0 of the job at the same time. Now, if they are not being scheduled at the same time, that is probably because they are competing for capacity on a finite resource. In other words, back to my example, left half and right half of a gear case being machined, maybe they're both going on a grinder, but if we have only one grinder, we can only grind the left half and the right half independently of each other, presuming that grinder on that grinding operation was set up as a finite capacity resource. So therefore, it's a resource constraint issue in this case.
Another interpretation of that too might be to fix that. You might want to pull that sub-assembly down as a material and make it make direct, and then you can make job to job demand link jobs. And that, because some people like that flexibility, then they can prioritize that, a lot of people call a sub job, to make that part either ahead of time to be ready for a certain operation. Because sometimes you can get caught in that tree where you're dependent on something else finishing, but really you can work on this part first. So making it a make direct part as a material in the job might help solve that as well.
So I can actually think of a couple of other scenarios here. Again, back to my left half and right half of the gear case as sub-assemblies within a job. Assuming that might be the case, and let's say we have only one grinder, but let's just say the grinder is capable of grinding a right half and a left half, sub-assembly at the same time. There's enough room on the machine to fit them both up, in the fixture and begin the surface grinding operation. If that were the case, there is available in Epicor, this kind of definitely goes outside of scheduling 101, but the concept of concurrent capacity. So in other words, what Zach introduced today was basically kind of a dichotomous relationship of either finite or infinite capacity, but there's actually something in between those, which would be concurrent capacity. And so, for example, using advanced planning and scheduling and concurrent capacity, we could explain to the scheduling engine perhaps that we can grind both of those parts at the same time without representing that resource as infinite capacity. In other words, what we're really talking about here, another way of saying this, is a non-time constraint. In other words, in this example, we're actually constrained by the geometry of the parts in the grinder in this case. So again, outside the scope of scheduling 101 for sure, but there are ways that, there's probably a lot of ways to crack that nut.
And I'll go down the slippery slope even further. That same scenario could be co-parts as well. I mean, you can set up jobs to produce multiple parts at once. So if you're making a left and a right, maybe they're molded at the same time, and you make 2 parts at once, so it would be under a single job. Again, we're getting up there in the scheduling land, but you can see how much we can add on and flex to what our shop floor looks like. So that's another possibility.
All right, hang in there, guys. Let's have another handful. What's the best way to eliminate MRP change suggestions?
So there are in MRP various horizons that we can set. And unfortunately, I wasn't really ready to go into the MRP topic. Zach, do you know the specific fields that we're talking about that can help us fine tune our MRP change suggestions, both in terms of a time window?
If we're talking change suggestions specifically, this is the same on purchase orders as well. You have lock check boxes. So on the job itself, you'll see two check boxes that say locked. One's up at the top by quantities. You can lock that in, or there's the scheduling lock at the bottom. So the scheduling lock says I don't want to change the date on this at all. It's locked in. The lock that the quantity says the quantity amount for this job is locked in. Don't give me any change suggestions for the quantity. So that should generate new suggestions or no suggestions then. That's the same on the PO side. On the PO releases, you can lock quantities and lock dates.
So yeah, and I think what it comes down to is, do you want to handle it on the case-by-case basis, in which case the quantity and schedule locks would be the case-by-case basis, or if you want to handle it as a rule, there's parameters at the plant or site level, depending on which version of the ERP you're running. But those are essentially windows, just like Zach showed you the finite scheduling horizon. That's the number of days forward in time beyond which we want to consider a resource finite. There's comparable horizons for MRP processing that can say, don't tell me to change anything within 10 days of, the schedule date or the MRP run date in this case. So again, a lot of options available to you there, especially when we get into MRP.
All right, next question. Does MRP consider supplier lead times from the parts table or supplier price list?
Yeah, I didn't touch on it, but in a lot of those scheduling screens, there was a checkbox called ignore constrained materials. So a constrained material does what you're saying. You're saying you can define it at the part level. So it's one of the check boxes on the front tab of your part. It's constrained material, and you're saying whatever the lead time is for that part is going to impact when the related operation can start. So it's going to use that date first. Also, when you mark a part purchase direct, material purchase direct, that's also a constrained material by default. So if you have a lead time listed on your material and it's purchase direct, that's considered a constrained material. And again, you can choose to run into your scheduling either using constrained material dates or not. That's with that checkbox. I don't think it'll just pick up like a universal lead time for the supplier, but it's whatever lead time is injected on your job there on the bottom of the screen. That's what it'll pick up, or on the sites tab of your part.
Correct. Like many other places in Epicor, there's kind of a cascading hierarchy, and as a rule of thumb, it's always the most specific case to the least specific case. So if we have a supplier price list with a lead time and that is the primary supplier. And of course, all this is assuming we're running that purchase part through inventory. As Zach said, purchase direct parts, different rules apply in that case, specific to what's configured on the job. Have we specified what supplier, and do we have lead time on that job material record?
Yeah, and it's important to note that with the buy direct, that's a constrained material, because a lot of people will get a schedule for a job and have no idea why an op's being pushed out. And it could be because you have a buy direct material with that lead time on it, which may or not be correct. Like, you may not have reviewed that. You may have an arbitrary 180-day lead time on a part because that's typical, but you can get it faster than that. If you're considering a constraint, that's gonna have a heavy impact on that job schedule.
Okay, next question. This is a mouthful, so hopefully you guys can interpret this. We are creating jobs for engineering products to use capacity and to track hours, estimate versus actual. If we have jobs that are unique from production jobs, so for example, if I have a 12345-ENG-1, is there a way to schedule only the jobs with the XXXXX-ENG-1 and not pull in the manufacturing jobs into my schedule?
No. Again, jobs are, scheduling is a site level activity. Now, what you can do, however, is, and it would be my recommendation, probably to use either product codes for those jobs to segregate them from as essentially manufacturing jobs versus engineering jobs. There's probably a few other ways to do that as well. But again, product code is the way we can essentially within Epicor slice up WIP, if you will, within a site.
Okay, next question. If I run job status search and pull a list of uniform jobs and dig in by part number and make the fixes to the part, will that uniform job fall off when the MRP runs again?
If MRPs run regen. Net change will not.
I'm glad you followed that one, Sam.
I'm trying to listen very closely because these are really detailed questions. Definitely not
really
scheduling
are.
101.
All right, next detailed question for you. I have a resource group that has 3 resources in it. When it schedules jobs, it always puts the jobs into the first resource. It doesn't move jobs into the other resources until the first resource is filled. Is there a way to fill the resources automatically instead of moving them manually?
It's probably twofold. If they're all not marked finite, if they're all infinite resources, it's most likely always going to pick up that first resource. And if they are marked finite, you got to make sure you're running your scheduling finitely to move on to the next one. Otherwise, it will do what you said. It's just going to keep looking at the resource group, picking up the first one it finds, and scheduling the job to that resource. So you need to be running finite scheduling for it to pick up the other ones, essentially.
Okay. Before I get into the next question, I have a lot of questions of people asking about the recording. Yes, we do record these. The recording will be available usually later today or early tomorrow morning. If you asked me specifically for it, I will go ahead and email it to you. If maybe you didn't and you were just curious, you can just drop me an email or reply back to your reminder email, and I'll make sure to get you that recording. So I just wanted to blanket that out there for everybody. Okay, next question. Is there a way to eliminate suggested changes to firm jobs in MRP job suggestions? Oftentimes the system will tell us to reduce quantity and create a new job for a job already in progress that cannot be changed.
I think it's that lock checkbox again on the existing job. If you mark the quantity, the lock checkbox in the quantity section, that'll be disregarded for change quantities. Then it'll say, nope, you've locked that quantity, and I'm not going to suggest any changes for it.
Yep, and again, same. I think this is a version of the same question we heard before, but again, there are some MRP horizons available at the site level if you want to apply those as a blanket, say nothing within 15 days is eligible for an MRP change suggestion, you can use the site level MRP parameters.
Mhm.
All right. What's the best use of planning time fence and reschedule delta in or out?
Good question. Definitely not scheduling 101. So I don't know, Zach, do you want to hazard? I'm aware of the fields. I'm not prepared to give a use case.
Yeah. When's the best time to use them? When it makes your schedule better. No. I don't think I could give a real definitive answer on that without more details about what the problem we're solving for. Usually that's something we will address if we're solving for a specific problem. So essentially trying to get the schedule to work better because it's not spitting out the one we want. So that's one of those things you kind of have to model and test in a specific environment.
Okay, so maybe we'll just take that question offline and address it kind of later with that person. Okay. How does a sales order that is marked as make direct and tied to a job affect the schedule job?
When you have a make direct job, you should get a job specifically for that order line release. So it's independent from your normal stock demand. So it's a one-to-one relationship. Hopefully that answers what you're looking for. So if there is stock requirements, it shouldn't affect that make direct job.
Okay, and I think, guys, this is the last question. Does the purchasing lead time work at a 5-day work week or a 7-day work week? And is the quoting lead times run by 5 or 7-day lead times? And is it able to be changed?
So yes, it's able to be changed. And the answer to all those is it depends on which calendar is controlling. And again, back to the Epicor principle of cascading defaults, we have a company default production calendar, which is the most general case. We have a site default production calendar, which is the next most general case. And then we can assign a production calendar at the supplier level. And so in the answer to, is it a 5-day calendar, a 7-day calendar, or some other number of days per week calendar, it depends which one of those is in effect for that supplier in question.
Okay. I was just running through making sure, but I think we addressed everything. Thank you, everyone, for hanging in there. I know we had a lot of questions, so I appreciate everyone staying with us. If you have additional questions, you can reach out to Sam or Zach or myself. The guys' contact information is up on the screen still. Obviously, our telephone number, you can reach any of us. Thank you so much again, guys. Terrific job. Everyone have a great rest of your day.
Thanks, everyone.